In this video, we're going to find the molarity of an unknown acid solution. So we use 25 milliliters of an unknown diprotic acid. And to that, we titrate in 0.075 molar sodium hydroxide until it fully reacts just as 37.45 milliliters is added. So our indicator changes color right then. Our volume added was 37.45 milliliters of the sodium hydroxide. Go ahead and pause, try to solve out this molarity, and then come on back. All right, if you're back, well, I've got my beaker. It's got a bunch of something in it, some H2A. And I'm going to add from my burette NaOH. So drop by drop, that'll get in, it'll start reacting, it'll react more, it'll react again, and eventually it'll use it all up. How much sodium hydroxide I add is going to determine how much acid there was present. So I need to know how much sodium hydroxide I added. 0.03745 liters of the NaOH solution. And in every 1 liter of the NaOH solution, there's 0.075 mole of NaOH. It's a diprotic acid, though. So for every 2 moles of NaOH, there must be 1 mole of the H2A. It'll take 2 hydroxides to take off the 2 H pluses. Well, the only way you get 2 hydroxides from sodium hydroxide is to have 2 separate sodium hydroxides, because every 1 diprotic acid has the 2 H pluses. So this is a 1 acid to 2 base relation. How many moles of the diprotic acid did I have to have present then? 0.001404 mole of my H2A. So we have the moles of our diprotic acid. And we have the original volume of it, so 0.001404 mole of H2A over 0.025 liters of solution that it initially came from. So that initial solution had 0.056175 molar H2A with 3 sig figs. 0.0562. So using a titration, by knowing the amount of one chemical that we've added, and knowing because of the indicator that we've added just enough to fully react the original chemical in solution, we can use the added chemical to find how much of the original chemical must have been present.